Right. Let me test the sound for a bit before we continue. Sounds good. It sounds good. Okay. Right. Before we do work, let's start with a game of chess, shall we? You can see that I've been playing here. This last game was super dumb because I was so winning. Rook takes. This is just dead. You have the knight here, which is basically pinned because once you move it, king takes, rook is possible. So you move this knight, and then I'm like, okay, check. I take the rook, easy, and I mouse slipped. And this is still a draw for me. I'm not losing because I just do this. But then I got so upset that I just insta resigned. But no, okay. Yeah, it was I'm gonna reclaim my win by playing a game and hopefully winning. But no, that win should have been rightfully awarded to me, but you know, these things do happen. We're listening to the Darino Fantavision original soundtrack by Soichi Terada, who is famous for other stuff as well. So you may have heard of him from that other stuff instead of the Fantavision OST, which is like this. Is it a puzzle game or something? It's like this, whatever this game is, PS2. Don't we just wait? No, we don't. Knight takes, queen takes. Or ignoring is also like a possibility. And push. You know, I might just ignore. I think taking is also fine, maybe even better, but this I feel is a bit less risky. Really? Okay, rookie coming in is a problem. So let's do this to stop it. The second problem we have is this thing over here. Also very bad. How do we fix this problem? Yeah, we're not... There are no winning chances for me in this game. But... there's really no chances for white to win either. Just go king here, I think. Because obviously push, bishop takes, rook takes. And if bishop here, rook here is a bit... I guess there's king f8. There is king f8. But I can just play king f8 straight away, can't I? Or maybe... I don't know. Yeah. King f8, d7, king e8 seems cool. Just break through. That's... That's fine. King e8. Or we can take, bishop take. Let's play this first, yeah? I should have maybe taken with the rook here to prevent the rook from coming in, because that was just an oversight on my end. Do I have to take? I mean, I think it's good if I take. There's push, pawn takes. Anything about this? Push, pawn takes. Bishop takes, pawn takes, bishop takes. Looks good because of the doubled pawns. And I get rid of this, all of that tension. So I will go for that. Is there an argument to be had for bishop takes first? Not really. Just king e8, right? I mean, Yeah, but no. Where is it best to put my bishop? Probably here. Oh, this is a bit tough. Because I don't know what to do. She's gonna check me. Nope, okay. What if I do this? You're gonna check me now, are you? Nope. Trade? Is that good? No, just play this. And now what are you gonna do? Just gonna give up. What? This is inefficient because this bishop here. No, do I just do this then? And okay, maybe I can't protect the piece because... Wait, no, I'm totally winning here. Take king here. Take. No, I just liquidate into an endgame that's clearly good for me. And I can win this easily with 46 seconds. Is stream working? Stream is working. Cool. No, that game was supposed to be a draw, he just blundered, like in the end game. I've never seen this flag before actually, what is it? Guam? What? What is Guam? Oh my god. I thought I knew every single country. It must be, yeah, it's one of those islands. I mean, I know every single country except for these tiny islands, tiny island nations that almost no one knows about. Of course I know Fiji, but like, I don't know, some of these other islands are basically invisible to most people. But that's a cool flag. What? It's an unincorporated territory of the United States. So it's not a country? Or is it? I don't know. Organized but unincorporated. $168,000? That's a lot of people actually. Bro. That's a lot of people. Puerto Rico is also a United States territory. Dude, what? Oh my god. I have to punish bad behavior. I mean, we have to disincentivize this sort of shit, cause time is precious, okay? I can't be dealing with this. I have work to do. I mean, I could just pre-move and like just do whatever shit that I want, right? I want to play one more game after this though. Just one more, okay? And then we'll do work. Basically, I have to, because this is the code that I have currently. I kind of want to reorganize it, because as it stands right now, it's kind of shit, as I'm realizing right now. So I'm gonna rewrite everything. One view, that's just me checking how the sound is a while ago. Dude, Anthony Fontoul, please. Why? please, you're not giving me a first good impression of Guam here. It's the first time I've heard about your country. Not being a good representative. Oh my god. Don't have the patience for this. Don't. Oh my god, what was that album? That looked pretty cool. It's gone now. There was like a baby or something here. But the good thing about this stream is I could look back at it and then just like take a screenshot or something. So, what do I do? Snipping tool. Just take a snip of that. That's a very creepy image. Oh my god. And then there we go. See? Coal Altar of the Deepers sinking slowly. 12k views with 4 comments. Cool, we'll give this a listen next. But yes, that's the good thing of having a stream. Otherwise that music would have been gone forever. And I would never know what it is. Unless the algorithm decides to recommend it to me again. But no, yeah, this is entirely a draw. Where was it? Right, so I had the choice to play, I think Knight Takes, which I think is okay. Yeah, it's okay. Knight Takes, Queen Takes. I was looking at, I don't know, Queen C7, Bishop C5, which, I mean, is an okay idea, I guess. Let's say B3 to do this, which seems natural. Then yeah, this looks really good for me, as the engine indicates. But I was a bit unsure. So Bishop E7, which is passive-ish, but also okay. Take, refuses to do the queen trade. Knight jumps in. Queen takes is okay. C takes probably is okay as well. Yeah, not super good. So yeah, queen takes. Okay, taking the queen is bad, but I'm not really sure where else I could have gone. Just back here seems... but the computer likes it slightly more. Yeah, I think I committed a big oopsie by playing bishop takes. Because I allow rook d1. So I should have taken with the rook instead. Because that rook d1 is annoying. But I still have this problem here with whatever's going on here that I have to deal with, which I guess I could deal with by playing like rook d7 and then pushing. So let's say random move, rook here, rook d7, another random move, c5 is okay, but oh yeah, but that's because the computer is freaking out because I can just play bishop takes there. So let's play a more reasonable move. I don't know, g3. Yeah, and then c5 to basically just untangle my shit. And then there's no problem at all with both of our positions, and it's just should be a draw. But yeah, I don't know, I wanted to keep my rook here just because I wanted to play c5 immediately instead of having to go through that process. But I didn't. I overlooked this thing here, which is still fine-ish because I get my king over to deal with it. Yeah, I could have checked, in which case I think I would have just ran over like here, right? That's fine. Yeah. Okay. One more, okay, one more. What is this? The Roziao Gambit. Oh, I think I remember how to play against this. Play d4. That's the only move, I think. And then knight takes. Oh my god. She knows the theory. This guy knows the theory. That's not the United States. That's Liberia? Is it just one star? That's looks a lot like... Shit, what flag is that? Colombia? No. What country am I thinking about? Whatever. Anyways, there's theory here. I know there's theory here. It has to be queen check, because knight takes, right? Takes, rook, queen takes, takes. That's it gets messy, but like I'm supposed to be winning here. The Roziao Gambit, whatever, is supposed to be shit. Oh my god, this guy knows what he's doing. Yeah, knight f6 is a move, and it does work. There's bishop g5, which, nope, that kind of sucks. Let's do this. Okay, giving up the rook. Curious, very curious. Could I have just gone here instantly? He could defend. Okay, I guess. There's push. There's push, yeah. Knight has to move. Can't move there because of queen takes. Let's say moves here. And then I don't know. Do we just defend the pawn? I think we just defend the pawn. And then we go for something like this. Okay, that's totally fine. We could trade, or we could... Are we up material or not up material? But his king safety is terrible, which means we should probably maintain our queen instead of trading. Maybe. Because the king is super weak, right? So we want to keep our initiative, which we do have initiative still. Knight d2, knight takes e4. Castle, bring our rooks in. Okay, he's defending the pawn, which is good, but I mean, this pawn is also under attack as well, so I'm gonna play knight d2 anyway. I think it's safe to take. Knight e3, maybe even I should castle pretty soon. Next move if possible. This is still Fantavision. I could do bishop takes. Takes. Because we are up material, so it would be fine to do so. Perhaps. If the queen were to run, where would I want it to run? This is fine. Or do I just want to simplify? Let me think. There's bishop takes, and then the queen would have to the queen here. Do you really want a castle here? There's like knight here and stuff. Castling the other way is also a bit unsure about that as well. But no, it should be fine. Because we have something like knight here, knight takes, pawn takes. Which will unleash our rook. Okay, that's not a bad move. Do we still have this here? Knight takes, pawn takes. If you take, then there's takes, but then you can recapture with the bishop, so that's not ideal. If you want to escape, there's really only one square. There's two squares, but knight here, knight takes, pawn takes. This knight's under attack. Sure. Ah, there's that move, which is interesting. This is hanging. Here, en passant, Pawn takes, bishop takes. Rook here. No. This is too hard for me to process. Oh my god, he disconnected. Good game? Why are you saying good game? This is still anyone's game. Knight here? Is the idea? Wait, no, it can't be like what pawn takes, right? And queen takes, there's no danger, really. So yeah, let's just... There's ideas of trapping the bishop, which we could look at. Oh, no, wait, bishop takes... No, I just... Wait, I blundered this one. Bishop takes, queen takes. G4, bishop falls back. Let's say here. We bring our rook in. Right. Okay, fine. Okay, we do lose this, but then... Okay, that's a pretty important pawn to lose. Do we just go with the other rook then? Or we could have gone with the queen as well. This is just a pawn push. Wait, might not be. But no, can't think. Yeah, this is okay, this works. Pawn push is safe. Knight here, rook takes. Knight takes. Whoa. What is this? This can't work. This can't possibly work. Expecting a check. Bishop takes, there's rook takes, yeah? Oh, I did not see that. I did not see that. Holy shit. Wow. No, I just lose. Well played, well played. I did not see that. Yeah, that was... Oof. No, This is just completely winning for me. I just didn't see that idea. Also, I had so little time left. This is completely winning. If I had seen that idea, just rook e3 is okay. Oh, I was losing here. I mean, fair enough, yeah. Oh wait, what? I was losing here as well? Now the Rosio Gambit is supposed to be, yeah, like I said, it's supposed to be super good. Just didn't know exactly how to play after this, because this is theory. d4 is theory. Not a lot of people play d4 when I play against the Rosio Gambit, because people don't usually expect d4 as a response. d4 is like the only legitimate response. There's d3 as well apparently, which works. I guess that's the more solid way to play. But yeah, I have to remember how to respond to d5. So bishop b5 is what you play, which makes sense. You pin. Let's say, what are the main moves here? Queen d6. Play c4, which makes sense. What if you try to unblock the pin? You have to play bishop takes c6. And then, well, bishop takes. And then I have to play queen h5. Let's say pawn takes, still queen h5. Okay, bishop takes, I have to play queen h5 here. And then now knight takes g6 works apparently. Oh, because I get my bishop out of the way. Because here I lose my knight and my bishop. But if I had gone out of the way first and then executed this idea, then I would only have lost the knight. So yeah, okay. Let's say knight e7 to protect, then what? Then castle, which seems natural. a6, what do? You just take, knight takes, I assume. Nope, b takes. c4. Yeah, c4 seems to be like something that you play a lot here. Okay, I should be fine. As long as I know bishop b5, then I should be fine for like the rest of the other lines, because those are moves that make sense. Yep, okay. That's fine. We'll stop playing for now, because otherwise we'll be playing forever. Let's try to switch. Is this good? It's okay. It's okay. Not super good, but it's okay. I mean, I just like to randomly scour for albums in case there's one that I really, really like. But we need something after Fantavision. We could get more Fantavision. Which... Sure. Oh, this is the same. could do Omori music, which is so cool. Ugh, okay. I'm just thinking if I should quickly make food or not before I start doing my work. I know I'm procrastinating a lot. I am procrastinating. I'm not making any excuses here. But I am hungry. So I might just go make food. And you guys can listen to Mori for like 20 minutes or something while I make food. Alright. Yeah, I'll make food. I think that's what I'll do. Right. I'll see you in 20 minutes, I guess. Wait, how long was I gone? Pretty long. Must be. An hour? I can check exactly how long. Right. It is an hour. Oh my god. Well, didn't intend for it to be that long, but well. Well. Okay. Um. Toilet. And then we start. I guess I'd have to review, cause there's basically two different paradigms when it comes to programming, which is object-oriented or functional programming, and I prefer functional programming. It just makes more sense. I haven't done any stuff in the object-oriented style before, but my supervisor suggested I switch to that. So we're going to, I looked at a few videos, but I'd still have to review it. 2 hour long? Really? This one's 3 months ago, so that might be a bit more relevant.
Hey everybody, so we have finally made it to Python object-oriented programming. This is a very important topic. In Python, an object is a bundle of related attributes and methods. Attributes are similar to variables. To
probably just that. Yeah, I will probably get by with like watching
by different real-world objects.
This just the first 12 minutes probably. Okay. I'm also not super like familiar with Python. I only just started like coding in it like right now, like as I'm doing this. So this is my first Python. The first thing that I'm doing in Python. Basically my first thing. I also need to know about like arguments and stuff. Args, kwargs. I need to re-familiarize myself with all of these concepts.
Next to me I have a phone, a cup, and a book. Each of these objects can have different attributes to represent it. For example, an attribute of the phone next to me could be version number. I could set that to be 13. Is on could be another attribute. Is the phone powered on or not? That could be true or false. Or even a price. I have a cup next to me. What liquid is within the cup? In this case, coffee. What's the temperature of the cup? Is the cup empty? is empty. Or even a book. What's the title of the book? That could be a string. How many pages does the book have? Pages could be another attribute. Now, objects also have the capability to do things. They have methods, which are functions that belong to an object. People mix up functions and methods all the time. They're technically different. Even when teaching, I tend to make that mistake, calling a method a function and a function a method. Usually people know what you're referring to, though. A method is a function that belongs within an object. What are some actions these objects can perform? With a phone, you can make a call or receive a call, turn the phone on or turn the phone off. Those could all be functions. With a cup, you could fill the cup, drink from the cup, or empty the cup. With a book, you can open the book, read the book, and close the book. An object is a bundle of related attributes and methods. They can represent real-world items. To create many objects, we'll need to utilize a class. A class is a type of blueprint used to design the structure and layout of an object. We need to design what our objects have, their attributes, and what they can do, their methods. We will create a class of car. We will create some car objects. Class car. To construct a car object, we need a special type of method called a constructor. It works similarly to a function. We will define a function of double underscore init, meaning initialize, double underscore again, and then follow this with a set of parentheses. This is our constructor method. We need this method in order to construct objects. It's a dunder method, dunder meaning double underscore. That's a future topic. I don't want you to be overloaded with information right now. All you need to know is that we need this method in order to create objects. This method behaves similar to a function. We need to set up the parameters. Self is already provided to us. Self means this object we're creating right now, this car. So what are some attributes that a car should have? A model, that could be a string, like a BMW. A year, that could be a number. A color. Let's add a boolean of for sale. Is the car for sale or not? That's true or false. To assign these attributes, we're going to access self. Self dot the name of the attribute. Self dot model equals the model we receive. These are parameters. When we receive the name of a model, we will assign it to this object. Let's do this with year. Self dot year equals year. Self dot color equals color. Self dot for sale equals for sale. This is an example of a few attributes that a car might have. A model, year, color, and if it's for sale or not, represented by a boolean. Now, to construct a car object, we need a unique name for this car. Let's just say car 1. Car 1 equals, take the name of the class, add a set of parentheses to invoke the constructor. We're going to do this almost exactly like a function. We have parameters set up. We need to send a matching number of arguments. Self is provided to us behind the scenes automatically. We need a model, year, color, and if it's for sale or not. So pick a car of your choosing. I'll pick my favorite car. The model will be a Mustang. For the year, I'll go with the recent year of 2024. A color, I'll pick red. Is the car for sale? I like this car, so no. I will set that to be false. Make sure false is capitalized. Let's see what happens if I attempt to print our car object of car 1. What we're given is the memory address of this car object, where it's located. But I would like one of the attributes located at this memory address. Instead of printing the object itself, we're going to access one of the attributes found within this car. We will follow the name of the car with a dot. This dot, it's known as the attribute access operator. I would like the model of car 1. That would give me Mustang. Let's access the year. Take the name of the car, car 1, dot, the year, 2024, followed by the color, car1.color, red. Car1, is it for sale? We'll print that. That is false. Now let's create a second car. We're going to reuse this class to create a second car. We will create car2 equals car. We'll pass in some different arguments. A Corvette. The year will be 2025. The color will be blue. Is this car for sale? Let's say that is true. Instead of accessing car1's attributes, let's access car2's attributes. That would give us a Corvette. The year is 2025. The color is blue. For sale is set to true. Or even a third car. Car3 equals a new car. We will pass in a string, the color. Then I will print car. The model is Charger. The year is 2026.
The problem is I have
For sale
to
is set
generate many of these objects. And I can't do that like by hand, I have to do it iteratively. So let's see if
They can
that's
take up a lot of
covered
space.
in
For
this
better
course.
organization, you can place them within a new Python file. So let's cut our class. And we will create a new Python file within our project folder. File, new, Python file. The name of this Python file is going to be all lowercase, car. Then we will paste the class that we cut originally. Class car, which has a capital C. So from our main Python file, we're going to import our car file, our car module. From the name of the module, car, import the name of the class, car. Then when I run this program, nothing should change. We should still have access to all of our car objects. You could either keep your classes within your main Python file, or import them if you would like to organize things. Let's talk about methods. Methods are actions that our objects can perform. Within our class, we will define a method of drive. Self is going to be provided to us. When we invoke the drive function, let's print, you drive the car. What other things can cars do? Let's stop. We will print, you stop the car. Let's take car1, access the drive method. You drive the car. Car2 also has a drive method. You drive the car. Same thing with car3. You drive the car. Let's access the stop method. Car1.stop, car2.stop, and car3.stop. These methods are identical for each car object. Instead of printing the word car, let's insert the model of the car. I will convert these print statements to F strings. Instead of the word car, let's add a placeholder. Let's add self.model. Self is referring to the object we're currently working with. Use the attribute access operator, followed by the name of the attribute. Let's also do this with the stop method. Self.model. Let's take car1, use the drive method. You drive the Mustang. Car1.stop. You drive the Mustang, you stop the Mustang. Let's do this with car2. You drive the Corvette, you stop the Corvette. Car3. You drive the Charger, you stop the Charger. Now within our F strings, let's insert the color. I'll add a placeholder, self.color. Do this with stop as well. Car2, last string, color. We'll take car1, describe car1. Car1 is a 2024 red Mustang. Describe car2. Car2 is a 2025 blue Corvette. Car3 is a 2026.
Right now I have to, Alright, let's watch
Hey
this.
everyone, welcome to Slice of Pie. Today's topic is star args and star quargs. So you may have seen these used before in some Python code and wondered what exactly they do. Well, I'm going to use them in this order pizza function so that you can get a better understanding of what's going on here. So first, I need to explain what the asterisks mean in Python. So let's say I have a list of numbers here. Now, when I print this list, we just print out the entire list. It's essentially just this one list object that contains all of these numbers. Okay, so in Python, when I add an asterisk in front of this list here and I print it, you'll see that it's actually printed each individual number. This is called unpacking in Python. This asterisk, when used this way, is called the unpacking operator. If it's next to some iterator like a list or a string, it will unpack the elements of that iterator. So back to our order pizza function, we can actually do this in reverse. Let's say we know for sure the first argument needs to be the size of the pizza. But what about toppings? That's going to change from order to order. This function needs to be flexible enough to take in an undefined number of toppings. Well, all we need to do here is put star args as one of our inputs. This actually doesn't need to be called args, it's just the typical naming convention. You can change it to whatever you want. For this scenario, I'm actually going to rename this to toppings. Okay, so down here, when we call the order pizza function, we can input as many toppings as we want. Python knows that this first input is assigned to size, but all the remaining inputs here get packed into this tuple called toppings. So watch, in this function, I'm going to print toppings. When we run this, you'll see that it prints out all of our toppings in a tuple. So in this function, I can say, we ordered a large pizza with the following toppings, and I can just create a for loop here to iterate through each topping and print it. So let's run this, and there we go. All right, so what about the star quargs? How does that work? So let's say we need some extra details for our order, like is it a delivery and how much is the tip? So in our function, let's add star details. Again, naming convention is quargs, but it can be whatever makes most sense for you. Down here, when we call the order pizza function, let's say delivery is equal to true and tip is equal to 5. So these are what's known as keyword arguments. These get handled by star details. The star toppings handled these positional arguments and put them into a tuple, and the star details will take these keyword arguments and place them into a dictionary as key value pairs. So up here, I'll print details in the function. And when I run this, you'll see that it printed our keyword arguments as a dictionary. So delivery is true and tip is 5. So we can use that in this function. So let's say details of our order are, and then let's create a for loop by saying key, comma, value in details.items. Then in here, we can print the key and the value. So let's run this, and there we go. And that's pretty much it. Hopefully that gave you some helpful insight on what star args and star quargs mean in Python. If this was helpful, be sure to leave a like, subscribe for more content like this, and consider watching some of my past.
Let me see some other videos. 1 year ago.
Hello friends, it's me again. Today I need to explain arbitrary arguments. Arbitrary meaning a varying amount of arguments. We don't know how many arguments the user is going to pass in when they invoke a function. To accept a varying amount of arguments, developers tend to use these parameters of args and quargs. Args means arguments. Quargs means keyword arguments. You would want to prefix each of these parameters with the unpacking operator, which is an asterisk. When you invoke a function that has args or quargs as parameters, you will pack all of those arguments into a tuple if it's args, or a dictionary if the parameter is quargs. Let's go over an example. I will create a function to add two numbers together. Define add function. There will be two parameters, a, comma, b. All I'm going to do is return a plus b. I will invoke this function, pass in two arguments because we have two parameters set up, 1, comma 2. Then I'm going to print the result. Big surprise there, my function returned 3. All right, well, what if I would like to pass in 3 parameters this time? Well, I can no longer use this function. The add function takes 2 positional arguments, but 3 were given. I could modify this function so that it could accept a varying amount of arguments, any amount. I'm going to replace the parameters with asterisk, then the word args, meaning arguments. So when we use the unpacking operator, what's going to happen now is that with the arguments that we pass into this function, we will pack them all into a tuple. And if you don't believe me, let's test it. I'm going to print the type of args. Then I'm going to remove this print statement for now. My parameter args is a tuple that I could work with. We can use the built-in methods of this tuple, or we could iterate over it. I'm going to iterate over this tuple. For every arg in args, for every argument in arguments, what we'll do is create a variable named total to keep track of the total. Total plus equals the current arg that we're iterating over. Then at the end, I will return the total. Let's print the result. Print, add these 3 numbers together. There we are. My total is 6. Then we can pass in any amount of arguments. 4 this time, maybe 5, or even 1. With my parameter args, you can change this name to something else, like nums, meaning numbers. For every num in nums, total plus equals num. This would work too. The name of the parameter isn't as important as the unpacking operator. Just by typical naming conventions, people tend to stick with args, but the parameter name can vary. Let's try a different example. Let's create a function to display somebody's name. Display, name packing operator, every name bill, name title, unique, which 2 unpacking keyword argument topic. I think this would be great for an address. Define print address function. Use double asterisks,
Then we can add a parameter name, but people usually stick with kwargs, meaning keyword arguments. Just as a placeholder, I'm going to type pass. Pass doesn't do it. I'm going to invoke this function, multiple keyword arguments, with states, fake street, state 54321. For me, that's just more readable, but you do you. When I pass in these keyword arguments, we will pack them into a dictionary of kwargs. Look at that, class, dictionary. Within this function, you can treat kwargs as if it's a dictionary. There's a lot of built-in methods, or we could iterate over the keys, the values, or both. To iterate over the values, let's say for every value in our dictionary kwargs dot values method, print every value. Here's all the values. For the keys, let's change this for loop to be for every key in kwargs dot keys method, print every key. Here are the keys. For both, you could say for every key, comma value in kwargs dot items method, print every key. Actually, let me turn this into an F string. Print every key, colon, value. The items method will return key value pairs. We can pass in a varying amount of keyword arguments. I'm going to add an apartment number. Apartment equals 100. Our keyword argument of apartment was packed into a dictionary along with all these other keyword arguments. So that's kind of nice. We can pass in a varying amount of keyword arguments. Let's cover an exercise. We're going to use both args and kwargs together. We'll print a new line. Then we will iterate over. I'm going to get the then kwargs number 100 PO statement kwargs.get PO box.
Right.
There we are. Dr. SpongeBob SquarePants, 123 Fake Street, PO Box 1001, Detroit, Michigan 54321. All right, everybody, those are arbitrary arguments. When you invoke a function, you can pass in a
default arguments.
Hey everybody, today I'm going to explain default arguments. Default arguments are a default value for certain parameters. The default is used when that argument is omitted when you invoke a function. In the last topic, we discussed positional arguments. Today we will be examining default arguments. Then in future topics, we'll examine keyword and arbitrary arguments. Let's begin. Let's define a function to calculate net price. There will be three parameters: an original list price, a discount, if there is one, and sales tax. We will return a net price, and here's the formula. List price times 1 minus our discount percentage times 1 plus our sales tax. Maybe I'm buying a PlayStation 5 for $500. I will pass in $500 for the list price. Well, I can't actually execute this function without also passing in an argument for discount and tax. Perhaps the discount is 0 and the sales tax is 5%, 0.05. Well, this would work, and I should probably put this within a print statement so you can see it. There we are. My total is $525. The list price of $500, no discount, and 5% sales tax. Now suppose that maybe 90% of the time when we're executing this function, most of the time discount is 0, and our sales tax is almost always the same. What we could do to make this function a little more flexible is to set these two parameters to have a default value. In place of sending in 3 arguments, we can pass in 1, then set our discount and our tax to have a default value. So I will set discount to be 0, and tax to be 0.05, meaning 5%. So this function would work. Our total is 525, and that's assuming that our discount is 0 and our tax is 5%. The nice thing about using default arguments is that, let's say that somebody has a discount. Well, this function would also accept up to 2 additional arguments. So let's print our net price, 500, and our customer has a coupon for 10% off. I'll add a second argument of 0.1. If we're passing in an argument for our discount, we'll use whatever's passed in rather than the default. Our total now is $472.50, or maybe this time, they are not paying sales tax. I will set the sales tax to be 0. Now the customer's total is $450. So that's kind of the nice thing about default arguments. It makes your functions more flexible, and it can reduce the number of arguments, especially if the arguments that you're passing.
Okay, what if you want tax, but you want to make the discount default? So if you want to set the tax to 0, but then the discount is default, which is also 0, it'll think that the tax value is the discount value,
Yeah,
no?
to be consistent. Most of the time people don't have a discount, and almost everybody is paying 5% sales tax. Why pass in arguments we don't have to? Let's cover an exercise. We'll create a count up timer. We will import the time module. To be consistent. Most of the time people don't have.
No, okay. They didn't cover, like, if the discount is... If you want to keep the discount default, so you don't input the discount, but then you want to change the tax to something other than 5%, then what do you do?
Have a discount, and almost everybody is paying 5% sales tax. Why pass in arguments we don't have to? Let's cover an exercise. We'll create a count function. The second argument is exclusive, so I'm going to add 1 to the end of our time. Then I will print x. To make this thread that's running the program sleep, you can access the time module's sleep method, pass in 1 for 1 second. Then outside of the for loop, let's print the word done. To invoke this function, I need to pass in 2 arguments, a start time and an end time. I'll set the start time to be 0, the end time to be 10 seconds. So we start at 0, then we will increment by 1 every second. I'll speed up the video, I think you get the idea, but we'll stop at 10. Let's assume that most of the time a user would like to begin at 0. Well, we don't necessarily need to pass that in as an argument. Let's set our start parameter to have a default value of 0. We only need to pass in 1 argument, but we do have a problem. Non-default arguments should follow default arguments.
Non-default arguments should follow default arguments.
So if you use any default arguments, you'll want to be sure that they're after any positional arguments. So let's reverse these. And that should work. So now when I run this program, it's assuming we'd like to start at 0, but we'll need to pass in an ending amount of seconds. When do we want to stop? That works the same. But now we do have the option of starting at a different number. This time, let's end at 30, but we will begin at 15. We're beginning at 15, then we will count to 30. I'll speed up the video.
But that's very
There we go.
unintuitive.
Everybody, so in conclusion, default arguments, they are default values for certain parameters. The default value is used when an argument is omitted. They can make your functions more flexible and reduce the number of arguments you have to pass in, especially if those arguments are consistent most of the time. So those are default arguments, and in the next topic, we will discuss keyword arguments. And well, yeah, those are default arguments in Python.
What is it? Oh, positional, okay. What is an arbitrary argument?
Hello friends, it's me again. Today I need to explain. Then I will function. We have a mix of arbitrary ends.
This is the same video.
I'll count
So
for every key.
that's arbitrary. Keyword we know, I think. Positional? Positional is just a normal argument, right? Just a normal argument.
Hey, James Murphy here with Encoding. We're going to have stars and slashes and stars, and it might be a bit tricky to remember. Here's the way that you should remember that everything after the star is a keyword argument. Recall what star args does. Star args eats all remaining positional arguments. In this case, our positional arguments are 1 and 2, which line up with A and B. There aren't any more positional arguments, so args just becomes the empty tuple. If we pass additional positional arguments, that's where they show up. Okay, great. Args swallows up anything that's positional. So logically, anything that comes after star args can't be positional. Otherwise, it would have just been part of args. So this is actually another way to force an argument to be a keyword-only argument. Anything that comes after star args or star whatever variable name must be a keyword-only argument. That's how I remember that everything after a star is keyword-only. I'm just imagining it's short for star args, but I don't care about the args variable. But the plain star actually has a benefit over using star args. Unlike star args, the plain star does not swallow up all the rest of the positional arguments. So this call, where I have 4 positional arguments, is an error. Whereas if I used star args, that 3 and 4 would just get swallowed up. This can be a problem because it gives the accidental opportunity to pass in something that you didn't mean to. You could check to see if there were any extraneous positional arguments that were passed in and then raise an error if there are, but that's just a lot of extra unnecessary work. Instead, just use a star and don't give it a name. Okay, but why would you want a keyword-only argument? Keyword-only arguments are most often used as options or settings that slightly vary or modify the behavior of some code. This combine function just takes 2 iterables and then puts them one after another into a big list. Maybe we want to add some kind of validation to this function. If you passed in a callable validator, then we check that all the elements are valid, exactly what argument they're passing in. Of this very plausible.
Okay. Now we have to see how to let's just ask ChatGPT how to make a lot of objects in Python, say from a data frame. Wait, what? Okay, persons. For blank row in Okay, wait. Let's just ask the regular internet. Create Python objects from data frame. This could work, but I'm just having trouble. Like, you can. Wait. How would I access these objects though? Okay. Yeah, this is exactly what I want. But wait, the thing is, though, Okay, probably dictionary. Huh. Hmm. Let me just think. Okay. Okay, I think I got it. Okay, so for example, let's say I have okay, whatever. I think I'm just going to okay. Okay, I'm gonna have this thing here. I'm just gonna call both of them marker data. Right. So we have marker data, we can print marker data just to see. That'll look like this. So we have marker and then we can access their length. So let's try to create an object with this. So first let's have a marker class. So if you want to make a class, that should look something like this. Class markers. Marker or markers? Just marker. We have a def it self. Well, the name of the marker. We also need its length. And that's self.name equals name. Is there a comma? No, there's no comma. Self.length equals length. And that should be it. There's repr, which is a method, but we don't really need that, I think. So that's our class. Now we want to add objects to that class. So yeah, we'll just do this thing, marker data dot toDicts. Does this work? It does work. Oh, so that turns it into that. Okay, that's interesting. And we're just gonna iterate over this dictionary, I guess. So now we have markers. Oh no, we'll do this. Right, so right. So this should work. What? Hold on. Wait, no, this should work. Just won't for some reason. I called it. Okay. Wait, no, this should work. For row and rows, this is rows. Wait, what? Oh! Oh my god. Because I haven't run this yet. Alright, that's so dumb. Now it works. Right, right, so we have markers, and then if we want to access a particular marker, we would do what's a marker? DPDC2, for example. Yeah, I mean we'd have that. Okay, yeah, let's add a repper just so that we could. No, actually, no, we don't need a repper. So that's the object. So we could do dot, no, okay, we could do dot name and then get the name of the marker, which should be the PDC2, and it is. We could also get the PDC2's length, and we get 8. Okay, that's cool. Okay, that's what I want. Okay, that will simplify things a lot. Okay, we're gonna do, okay, that's the marker class. This is marker objects. Right, now we want to do the same thing for samples, for our samples. This is gonna be a bit more complicated, very complicated. Let me just think about how to do this. Okay, right. I think we might have to ask ChatGPT for this. But no, it's hmm. Or we could do a triple, and then access the data from there. Wait, no, I'm just thinking about the most efficient way I can do this. Well, this is so hard to think about. Um, hmm. I guess I can ask ChatGPT. Samples. For each sample, measurements are made on multiple markers. This microsatellite markers includes the frequency at each allele, sample, sample 1 at microsatellite at marker 3. Allele is 0.3, and so on. How do I record this? How do I create a class for this? Wait, but that doesn't make sense. Oh, okay. This could work, but it's a bit ugly. Wait, does this work? This does work. But it's just. It's just not cool. So dictionary has a key. Um. Oh, okay. I see. Okay. It's starting to get to my head. Okay. Okay, wait. Okay. Okay. So we could mix both functional programming and object-oriented programming. We could make a no, but that's I'm just trying to think super far ahead about what I want to do, because if I make a mistake now, then I'll have to change the design again. This is so ugh. Okay, I mean, okay, this could work, okay. Alright, so you don't need this per se. Right, so let me just double check something. So if rose is a dictionary, then we but then wait, how do you do this? Let me think. I could do something dumb, but like for row and rows, if row marker equals marker then set x equal row ms.length, or just len. Else len equals 0. Wait, no, this won't work. So we could have len equals 0 here. Or we can just do return. Return row ms.length. So if I want to get like the length of the PDC2, then alright, we have to run this function. And I get 8. Cool. This is super inefficient though. I know this is inefficient. Oh my god. Wait, no. Wait, wouldn't we just... Okay. Now we just do lengths, and this should just give 8. Bro. Okay. That's just it. Okay. Nice. That's it. Okay. We don't need a marker class now. That's a bit unnecessary. Right, so we can access the length of a marker by just putting that in. Okay, that's cool. Now for this, now we just have to copy these guys. Wait, but really though? So like you're creating a marker object with this, but then the ID is the same, which wouldn't that be troublesome? Is what I'm thinking. But now we can try it. We can just try it out and see if it works or not. Is add marker even used? It's never used. Add marker is never used. Just marker name. Wait, what? Okay, okay. I see, I see. Let's try to import our CRC data. CRC data. So if we read our CRC data, that'll look like this. Which is like, okay, that's cool. So let's see. Sample objects. So we create a dictionary, we just have an empty dictionary for now. Is there iter rows? CRC data dot iter rows. I guess, yeah. This is not even on here. Okay, whatever. Line 26. Class marker. Mm, what? Okay. Oh. Oh god, it actually worked. Okay. Should do CRC samples. And then alright, so let's take a look at some samples. So CRC samples, and then we're gonna take a look at one particular sample. Let's say the 103 sample, and we want to do a / repr on this object. We need one more. What? I thought we've defined these classes. Oh wait, no, repr. Wait, how does repr work again? How does repr work? Because we don't call it normally. Oh, okay. No, okay. So if you just use print, then that should use repr. Okay, very cool, very cool. Okay, so let's say we want to so markers gives a list of is a dictionary. So we could call a specific marker DPVC2. And then this is a marker object. So you could do dot allele frequencies. And then we do, let's say we want the -2 allele frequency of this. Okay. Cool. This should okay, yeah. Okay, this does make things slightly easier to deal with. Maybe. Okay, yeah. Let's just see what happens if you do something that's not like yep, key error. Okay. Okay. Let me see. Let's try. To use this object to make a data frame. How would I make a data frame from this? So I'll have like a sample list. Hmm. What do I do? What do I do? Wait, oh my god, this is so confusing. Hmm. Oh, this is so confusing. Wait, none is this thing, right? None. Okay. So we have gene MMR type. We'll do MMR and then type. And gene. Oh, okay. Let's see. We should ideally convert okay. When gene is sporadic or MMRP. How do you do or? Okay, or. Alright, so this. Okay, maybe we do that and that. Wait, what? Or in Python? Dude, I just want or in Python. I just have to say or. What do you mean ambiguous? About now. Okay, that works. Let's look at it has to be small. With NEN also. NEN. Nope. Yeah, it has to be none. So this should ideally only have genes. Okay. These I have to delete. And I will delete these. This is bad data. 0, 0, 0 is just not good. Okay, we'll do that later. MMR, and then we'll redo all of this to create the thing. So what do we want next? Don't need to touch MMR. We just have to touch type. So if type is MMRP, we just convert that to none. Ugh. Otherwise, type is type. Alright, we have to do that. Now we get none. Okay. Cool. Okay, now let's remove, or we can just do, say, remove these. Okay. Oh shit, there's a lot of these open things. Okay. Remove rows based on index polars. Wait, what? Hmm. So if you slice 1 to 2, that cuts 1. Let's say sliced equals CRC data dot slice was it -3, 1? Then we'll have to just test. Wow, I only have 1 data here. Okay, oh, -1. Alright. Yeah, I'm only keeping that, which is not good. Ooh, okay. One until -3. Hmm. Oh. Wait, what? But this is the opposite of... So, we're cutting from 1 until -3, which is all the way down here. So we're cutting that off and then just having the rest. But then this has the opposite effect of what's been shown here. Weird, very weird. Okay, but we removed the bad data, which is good. Okay, that's very good. Okay. Now there's no right CSV. Uh, can I move it? I can't move shit. Okay. There you go, move into raw data. Right now I can do this and then just shabam. And then okay, that's good. So 103 is a sample, and then let's say we want to know the MMR status of it. Oof, okay, wait. Okay, this should work now. So FCRC samples, and then we have sample 103, and we want to say what is its MMR status. It's MMR deficient. Okay. It's MMR deficient. Okay, what type is it? Sporadic? Is it Lynch? It's Lynch. It's Lynch. Okay, what gene does it have? MLH1. That's the gene that is mutated. Okay. Alright. So we have all of this data now. We can easily access the data for each sample. Okay, let's say the marker. Okay, the marker DEPDC2 or GMO9. Let's say GMO9. Let's say in GMO9, is it markers? What? Okay. What's it called? What is it called? It's small letter. No, let's make it big letter. Just standardize it. But then we would have to make this guy big letter. Make this guy big letter. This guy big letter. Okay. I just have to redo everything again. this, and this. Okay, so CRC samples. Maybe I should call it CRC sample. Okay, so we have a CRC sample that's called 103, and I want to see markers or marker, just marker, yeah. Marker, then we do this, we do this, we do this. Okay, that. Okay, so let's test this out then. CRC sample. We have a sample called 103. I'm going to take a look at a specific marker called DPDC. Let's do GMO9. And then I want to look at the -1 allele of that. Wow, okay, no. Allele frequencies. Can we change that into just allele? Just so that everything is super easy. Okay, so CRC sample 103 at the marker GMO9. And then we're looking at the -1 allele. Okay, cool. Our data is in a good format. Now, the question now is, from this, how do we create a table? Because if we want to plot something, we need to make a table. Test table. Test data frame. Wait, make a data frame in polars. Make data frame from objects. But we have our data is like nested, so this will be interesting. Hmm. 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 I mean, do we need to? Or do we just... Hmm. Oh my god, this is so hard. Right. Hmm. It's so hard to think differently. To think in terms of objects instead of in terms of functions. And I can access things easily, but how do I actually use it for like my purposes? Wait a minute. We do have like a marker list. How does map work again? Python map. The function, but the function can be a lambda x. And then this can be CRC full marker list. Wait, do we not have an example of map here? To list. Wait, what? Oh, just do that. Ooh, okay, cool. Let me do that. Oh, okay. Okay. Well, if I do this, then what does it turn into? Also a tuple? This set. I'd rather it be a tuple. Okay, I think I have an idea of how I can make use of this. Okay, I think I might have an idea. But we'll continue this next time, I guess. Okay, this is helpful. Okay. Oh no, let me think a bit more. Oh my god, okay. Okay, let's see def function 1 sample. And we return not x sample. Wait, why is this wrong? Oh, return. Okay. Now we do yeah, we just do list map again. This time it's function 1. And then we have full marker list, now we have full sample list. Okay, maybe add sample here as well. there's something without this negative non-alveol, then it'll just return an error, which kind of sucks. A a none instead of an error, maybe. So for example, def function 2 error marker. A function return none if error. What does still has an error, but I accounted for that. Interesting. So GM11. Oh, okay, no. LO255 LR20. LO255. And it's the marker LR20. Yeah, it doesn't have one. Interesting. I think it's better to put a 0 in. That's interesting. Okay, yeah. I mean, okay, yeah. I think I can know how to make this work now. Okay. I will. Yeah, okay. Yeah, this is okay, okay. Yeah, I can make this work. Okay. I will see you guys next time. Because this is taking so long. But I think I get what I want to do and how I want to approach this. But I'll continue later. Goodbye.